Okay, here we go.
All right. Thanks, Randy. Brian Goodwin, Technical Director here at ABYC. I haven't met you. Come say hello. I've met many of you, presented in front many times. Great to see that we have some international folks on there as well. So yeah, I'm going to talk a little bit about ABYC and our standards and what we're doing in the world of lithium. To advance, there you go. So, you know, the first question is, who is ABYC? Really, when you look at us, ABYC was formed in 1954 in a response to increased boating accidents and fatalities. We came together really as a group from some insurance folks looking to reduce those fatalities, and we're formed. We've evolved over the years, and really, when you look at it, you know, we kind of do several things. The first is standards, voluntary consensus-based standards for small craft, right? And what's a small craft? Well, it just depends what you define as a small craft. We don't have a formal definition that says it stops at 100 feet or 24 meters, like ISO tends to go for their small craft, goes less than 24 meters. ABYC doesn't do that. So standards, variety of, we also have technical information report. Those are informational documents about a particular topic. We also do education for the industry. We have 9 certifications that are available. A couple of those are available online. We actually have virtual classes as well. Everything from standards-based systems, electrical is a real popular one, and corrosion. So that's another part of the 3-legged stool, I like to say, that's the ABYC. And we are a membership organization. That's how, you know, we keep the lights on and put food on the table, is through membership. That gets you access to the standards and to the educational aspects. So if you're not a member, highly encourage you to become a member, because it gets you access to all that great stuff. So, you know, talking to surveyors, a couple of benefits. I always like to point this out to you. We do have a surveyor directory. So if you're an ABYC member and you haven't checked a certain box in your profile, filled that out, do so, and I'll show you how to do that. So that way you show up on the directory. So if a customer comes and searches, they can find you. Now, if you don't want to be found, don't fill it in. You won't show up there. So obviously, this is a consumer page that we have, and you can see where it says find a marine surveyor, and you can search. You can search on a number of areas, facets, such as the location, state, geographic by name. Here we found Frigate Marine Services here down in North Carolina. So we're going to look at them. Now, in case you want to update your profile, once you log in, you go to this page here and you see where it says manage my profile, and you can take you down into this page and you can see edit bio. And I'm going real quick because I know I stand between you and lunch. So that's a very important meal today. So on this page right here, under your profession, that's where you want to select surveyor, and that'll get you pulled into that directory. So real quick there. All right. So standards, really, that's one of the primary things surveyors want. And they have 3 main ways they can access the standards, right? You have the tried and true book, doesn't require any power, doesn't require anything. You can take it wherever you want. So it's some people prefer that. We also have our online library, which has the standards as well as other documents on it, that has a nice search engine, so you can find what you want. We also have what we call our desktop subscription, which is a program that you can install on your local computer and have access to the standards. When you're connected to the Wi-Fi, you can click a little button to sync and it'll pull down the most current standards. So 3 ways. So standards library online, right? You have, again, a variety of documents. You have some excerpts of the federal regulations here in the US. You also have the federal compliance guidelines, right? So this is a great way to help understand what, you know, the federal requirements are versus the ABYC. So you have ICOMIA comparison documents that compare ABYC standards to ISO standards and vice versa. This is useful for builders that predominantly would build in one set of standards and they're looking to go into another market. It helps them identify the additional things they may need to do or things they need to do differently. And then we also have ISO standards that are available for an additional charge as a subscription. You know, when you get into it, we just published supplement 63, right? Standards are on a review cycle. Most of our standards are reviewed every 5 years, but a couple are on a 3-year cycle, such as electrical. And we published this overview document that really highlights what has changed in each particular standard that has been updated. Obviously, with over 80 documents, we don't publish we don't update every standard every year. But these are just the ones that have been updated. Here's an example. Again, you can these are the sections that have changed in the standard. We also have related documents. This is a great way to see what the previous version looked like. It also has what we call track changes here. So you can kind of look back one standard if you want to. And here's an example of the track changes, right? Underline strike through format tells you exactly what has changed. All right. Also in the front of the standard is the summary of revisions. It's a bulleted list of the major changes that are changed in the standard. So again, another quick way to understand what may have changed from this year to the previous version. So yeah, supplement 63 just published, right? Came out end of July. So that is the current set. You can see up on the list what has changed, what has been revised. I'm not going to go through this. If you really want to know what's changed, I did update webinar that's available on our online learning platform, free. So you can go take that course and you get to hear me talk about all these standards. 13 revised, 1 technical amendment, and we also had 1 component standard that was also updated. All right, so what's going on this year? I always like to put this out there because you get surveyors that sometimes go, you know, this needs to change. We don't like this. So these are the standards that are currently up for review. They're going to be reviewed this year, most likely published next July. So if you see something that you want to change, you know, get involved is what I say about that. We use a committee system, and you can be placed on the mail list for that committee. So you can get all the correspondences, the notices, you can submit comments, you can come to the meetings, you can participate in the meetings. If you really want to get involved, then you can pursue becoming a member of that committee. So that's the next step there. So www.abycinc.org page/get involved if you want more information. We are going to have our standards week in Annapolis, Maryland this year. So if you guys, a lot of you are local, if you want to come check it out, you can show up, participate. Make sure you register so we make sure we have a seat for you. You're not standing the whole time. All right. So really what you wanted to hear about right in the hall. I heard everyone say, oh, lithium batteries, they're so dangerous, so bad. You can't have them on boats, right? We've had things like the Boeing Dreamliner where they struggle with lithium batteries. And you know, if a mega corporation like Boeing can't get it right, how's the marine industry going to get it right? You got a BMW, right? It catches on fire, showroom starts smoldering. What do? They have to bring in this basically a roll-off container. They fill it with water and they drop the whole car, and talk about an insurance loss there. So really, lithium batteries have had some bad press, and they've had some issues and challenges. But really, when we start talking about lithium, we got to understand a little bit more about it, what it is, why is it bad, what's the hazards associated with it. So, you know, but really, before we say why it's bad, let's talk about why it's good. Why do people like it? Why is it even showing up? And the magic thing you hear about is energy density, right? How much energy can you get into a given form factor for a given weight? So this chart, you can look at the various different chemistries that have been out there, and lithium ion, you know, from a size perspective, it's smaller. You can get more energy in it from a size perspective than lead acid. And from a weight perspective, you can get more energy for the same given weight than lead acid. So smaller, more energy, lighter, and in a boat that you want to float, these are all positives. The other thing is it has a different discharge curve to it. Lead acid slowly drops off. You can kind of figure out the state of charge of a lead acid battery by simply looking at the voltage. Lithium, you can't really do that. It has such a flat discharge and then suddenly drops off at the end, as well as the high end. So you need to make sure you have a shunt in there that basically measures what's going in and out of that battery to establish what its state of charge is. Now, we talk about this, right? This is supposed to be the end all be all, but when you compare lithium to other liquid fuels, like replacing gasoline, diesel, petrol for our international folks there. This is the same kind of energy density chart here, and you can see that gasoline still has a lot more energy when you compare it to the same volume weight of batteries. So we're not there yet. It's not a 1-for-1 from an energy perspective. The other thing I really need to stress, and I'm going to talk about that, is lithium is it's an umbrella term, right? Everyone uses it all the time. Oh, my cell phone has a lithium battery. My laptop has a lithium battery. It's an umbrella term. They all have different chemistries. There are multiple different chemistries. And chemistry matters when you're talking about lithium batteries. Every chemistry has different properties. And from a safety perspective, from an energy density perspective, it matters. So we're going to talk about a couple of the common chemistries that you have out there, and really what you'll see here. And this is a nice little spider chart. When you look at it, you can kind of see the difference in properties for a given chemistry. So you can kind of see what's better, what's not good. Lithium iron phosphate, LFP, is really one of the predominant ones we see in the marine industry. And from a safety perspective, it's good. From a capacity, it's not as good as some of the others. So again, it's application specific, and we'll take a look at those. So again, it's all chemistry. Lithium cobalt oxide, find that a lot in laptops, cell phones, and cordless tools. Again, not what you're seeing in boats so much. These are the toys, whatnot, and so far most of these have a good track record. Lithium manganese oxide, this is what you see in a lot of cars, some of them in the newer there, and you can kind of see, again, energy density, cell voltage there is just a comparison there. Lithium nickel cobalt aluminum, the reason I call it the cobalt is anything with cobalt tends to be a little more volatile, right? So those are the chemistries you really need to worry about a little more when you get, say, the Teslas, right? And everyone's like, oh, the Tesla was submerged and it burst into flames. Well, again, it's a different chemistry than LiFePO4, which I think is the most predominant one there. And then you get submerged, you get high resistance connections, they burst into flames after the hurricane. It's problematic. So lithium iron phosphate, this is the one, again, that I've seen mostly in the marine industry. It's a little safer than the others per se. You see it a little more here in drop-in solutions as well as larger banks. It's probably the largest from a production standpoint as well. So, right, again, it's a battery. How does it work? Cathode, anode. Basically, you have electrons flowing in one direction when you're charging, in another direction when you're discharging. So you actually never have. Do you want me to admit this person that wants to?
Oh, yes, please.
I don't know who he is, but hopefully
No,
he's
fine.
good. So really, you never actually have the lithium metal form in this equation if everything is working properly. Again, we're just pushing ions back and forth, moving electrons back and forth in this process. We use graphite as your typical anode in this equation. So again, some comparisons. You've probably seen this. This is readily available data. It's really comparing a lead acid, right? A flooded lead acid group 31 to an equivalent group 31 lithium iron phosphate battery. And some of the things that may jump out to know is, one is the number of cycles, right? That top line, number of cycles. Lead acid, you're probably getting definitely under 1,000 cycles, depending on how deep of a discharge you give to that. Whereas lead acid, if you're only discharging to, say, 50% of the battery, you can get 13,000 cycles out of that battery. So it's going to last much, much longer. So that's one thing that you'll probably see is these batteries in the field for a much longer time period than your lead acid, right? How many of you written a survey and said, oh, batteries are shot, replace them, not a big deal, right? They pull out the lead acid, drop in new ones, because you're only getting, 500 cycles, 900 cycles out of those. you know, and when you look at that depth of discharge, that really impacts your usability, how much of that battery you can actually use. You can discharge a lithium iron phosphate down to, you know, typically they say about 80% you can use, whereas lead acid, again, a lot of times you're only doing that top, you know, 20, 30, 40% of that battery if you actually want to take care of it. So you can actually have less battery on the boat if you start thinking about that perspective, because you can use more of it. So maintenance, there's really not a lot of maintenance associated with a lithium. Lead acid, depending if it's sealed or not, you could have some maintenance there. So just some other things to consider there. Thermal safety, right? That's the thing everyone thinks about. I talked about the Boeing, the BMW, and really you're looking at this thing we talk about, thermal runaway. And it's important to understand that it's a chemical reaction. Temperature impacts the chemical reaction. I don't know if everyone remembers chemistry back in their schooling way back there. But when you start comparing those, one thing to understand is that lithium iron phosphate takes a much higher temperature before it really starts falling apart, degrading. It starts releasing the oxygen that really leads to catastrophic failure, right? Thermal runaway fires. The other chemistries are much lower temperatures. So, you know, you're looking lithium iron phosphate, you're 350 C over 600 degrees you have to get, whereas the others you're at 150 C, 320 degrees up. So that's a huge temperature difference there from that perspective. Longevity, we talked about this a little bit before. Again, you can see the straight long line is a lithium. It doesn't get that memory, it doesn't get the sulfation going in there, and it'll last much longer. Really, when you start looking at higher loads, lithium does better with higher loads. The red are lead acids versus lithium ions. And again, this is chemistry. Puchert's effect comes in, and then how quickly you can discharge versus and still maintain without dropping below critical voltage there. Charge time. Lithium takes a faster charge. And really this starts coming to play with how they're applied, where they're put, and how they're used. Because it'll stress systems in an existing boat. If you switch out the system, you know, that alternator is going to be stressed compared to what it used to have to do, right? Because the lead acid just can't take the same charge rate that a lithium can. So that lithium will just say, bring it on, I'll absorb it all, right? So that alternator is working as hard as it can trying to provide that. So something to consider. Depth of discharge, we talked about that, more usable energy, lower self-discharge rates. So from a storage perspective, I've had some sitting in my garage probably for almost a year, and every once in a while I'll go stick a meter on them. They really haven't discharged, whereas the lead acid would probably be flat and dead, and not very useful at this point.
Brian, isn't that where they're finding some of the batteries that have been, you know, that have caught fire? They're still holding energy in there.
We're going to talk about that later.
Okay.
We're getting there. Yeah, that's a valid point there.
But I know that we talked about that in work last year.
Yeah.
How
Okay.
much residual that was left behind.
This might look a little familiar.
What's
So.
that? Okay, I can't get enough.
All right, good. So really, you know, from a standards perspective, what's out there? What do we look on? What do we rely on? Because from a US federal regulation standpoint, there's nothing out there that a surveyor can point to. And in the recreational boating market, on the commercial side, I think the Coast Guard does have some guidance there. But really, ABYC came out with E13. It's a standard that addresses lithium ion batteries. It started out as a tech info report first, and in 2022, we published it as a standard. So what does it really apply to? Lithium ion batteries, again, the design, manufacturing, it applies to really the systems installed boats over 600 watt hours. And you're going, well, how much is that, Brian? I don't know. So if it is a typical 12 volt system, that's something over 50 amp hours, right? And that's about anything larger than that it addresses. But you have to remember, these batteries end up in a broad range of applications, right? It's not just a house bank. It could be for propulsion. They could be for trolling motors for like bass boats and smaller. That's where I'm seeing tons of these drop-ins added is in that bass boat market. Because it's lighter, more power, whatever fisherman wants, make his mean fishing machine there and runs trolling motor. So really broad application of where these batteries end up. But what the standard does not apply is consumer products that plug into receptacles, think cell phones, laptops, aquatic toys, right? So that's a big issue when you start getting into larger yachts is you get these aquatic toys, ski bobs, the foils, and a lot of times those have different chemistries. They have the less stable chemistries. They get treated kind of harsh, and right. Someone was talking about, oh, the fires in New York, the e-bikes, again, different chemistry. Those aren't a lot of times using lithium iron phosphate. They're using a different chemistry. They get treated harshly. They're more likely to go into a thermal runaway condition. So this standard doesn't address really those toys per se. One of the key things it requires is the batteries to comply one of the standards. It gives you, quite a list to pick from. We're not going to say it must comply with an explicit standard here. And one of the other things that's called out in this section is really when you're looking at it, right? Lithium ion batteries, the way they're designed and built, there's no easy way for them to spill their electrolyte. There's no easy way for them to vent. They're sealed. They're sealed cells typically in a box. So some of the concerns that we typically had from a ventilation perspective with a traditional lead acid battery aren't a concern with lithium batteries, unless something goes horribly wrong. But so the other thing to really think about is when they're installed is follow the manufacturer's requirements. They're gonna just tell you what you need to follow, right? Where they can be installed, what paradigm you need to follow, what you need from any kind of overcurrent protection. Oh, of course, you need to follow our overcurrent protection requirements, but they're going to give you some of those guidelines into where they should and should not be used. Stay within the SEO. What is SEO? Safe operating envelope. Okay. You can kind of look at the safe operating envelope in a couple areas. The first one is temperature, right? You want to make sure that these batteries don't end up in a space that is too hot, that exceeds the manufacturer's recommendations from a heat perspective, right? Because we don't want to get them too hot. You also need to look at the cold side of it as well, right? So once you start getting below freezing, these batteries don't like to take a charge. They really shouldn't be charged, and the PMS actually cuts that off. So you also need to look at the charging rate. What is your equipment that you have, and making sure that you are staying within that, as well as the discharge rate, right? So I alluded before, you kind of have this thing called a BMS that deals with some of this. So all these things can have an impact on the battery. So and really what there is to make sure all this stays within this SEO is a BMS, a battery management system, right? It's looking at the battery, assessing its condition to try to keep it in a safe envelope. It's really the brains, and these may be internal, and this is something that the ELS or E13 requires is a BMS, right? So the BMS could be internal to the battery. And you see that in what we call drop-in batteries. It's built right into it. Or in bigger systems, it may be external, right? It may be hanging on a cabinet somewhere. It may have its own brain out here as you have multiple batteries. The most important thing is that you don't bypass the BMS, because that is what's trying to keep the battery in that safe state. Charging sources. Again, I kind of alluded to this before about alternators. You really got to take a look at alternators to make sure they're going to be able to handle the charging, as well as if you're replacing batteries on a boat. If you have an older boat, that's a lot of times what surveyors look at. If the batteries have been changed, is the charger appropriate for those batteries, right? Does it have a lithium profile, or are they still trying to run on a lead acid profile or an AGM type profile? Typically, you don't have a float in a lithium charging profile, right? It charges it up gets it there, and then it shuts off and lets it sit. Then eventually, if the battery comes down, it starts over again. Whereas lead acid, you'll typically have a flow. Installation, some key installations. Again, the requirements are to follow the manufacturer's requirements from an installation. If they are not provided, there shall be no visible movement of the battery. So this is different than what we require of a lead acid battery. A lead acid, we allow up to 1 inch of movement. Here, we basically say that they should not have any visible movement, so they should be securely held in place. Battery switch is another thing that I'm calling out. That's really an E11 thing. That's called out here as well. Again, because typically these are larger batteries, so you're going to need a way to be able to disconnect. Overcurrent protection, obviously, is called out by E11 in these systems, right? Overcurrent protection is to protect the conductor of the battery, and as I mentioned, secured properly. Again, common number of connections, just like any battery, we want to make sure we don't exceed more than 4 terminals on any post or connection. So we talked about this. The standard also has an appendix that talks about thermal runaway. And you can kind of see here, you have a chart that kind of shows a couple of different scenarios on how you could get to thermal runaway. And really, it's once you get into thermal runaway, it's a self-propagating heating condition that can occur within the cell or cells. And a lot of times what will happen is once it starts in one cell, it starts spreading and spreading. And that's the problem, is it's creating its own oxygen source and its own fuel source at this point. So as soon as you have that enough heat to auto ignite, that's when bad things happen. In this case.
Did the BMS take care of that runaway?
So the BMS typically tries to keep the battery from getting into to get there in the first place, right? Once thermal runaway starts, the BMS isn't going to do anything, right? The BMS isn't going to go, oh, let me turn this off. At that point, it's already gone.
Do they have any alarms that would say that reaching that thermal runaway?
So usually, as long as you cut off, right, you take whatever the outside influence is that's causing that problem away, you're not going to get there. So some of the BMSs can provide notice depending on, again, depends on the application and installation. The standard does not require a warning, but some of the systems, like if you get a bigger system with an external BMS, it can provide that information. The typical drop-in solutions aren't going to provide that. So again, things to be aware of: temperature constraints, alternator, load dumping, right? That's the other thing with the alternator, is if the BMS suddenly cuts off, what happens to your alternator? Doesn't like that too well, does it? No. So flatter discharge curve, again, so you typically need a shunt in there to understand it. Cranking, I'm not seeing them utilized in a lot of cranking circuits, again, because you got a big inrush in those, as the BMS is going to set the maximum discharge for that battery, right? So that's a BMS parameter. So there, you got to really take a look at that. Again, this is just a fun little chart where you start looking at potential causes of battery failure. Right, you can have mechanical abuse, electrical abuse, thermal abuse, and depending on what happens, you're not always going to get to a thermal runaway. You may be able to shut it down before it gets to that point. That's the whole goal there. So I like to talk about this next section as really, you know, what would my brother-in-law do to my boat, right? So my backyard testing, we went and purchased some lithium iron phosphate cells off the internet through eBay. So not a reputable source, just off wherever we could get them. And you can kind of see them there. And then we decided to see what we could do to them. You know, the brand was generic, so we're good there. Who knows where they came from, where they were made. You got to max max charge voltage in the literature that said it was 3.65 volts per cell. So right, we're kind of looking at a 12-volt system. So we stack 4 of these together, and we basically built ourselves a 12-volt battery in here. I like this. It says, you know, a continuous just 1C rate for a continuous discharge. 1C continuous, they misspelled continuous. Again, confidence in the product here from a charge rate. So you discharge and charge, you're saying you can do 1C. And they recommend lock nuts recommended. So again, excellent literature, quality proofreading. I'm being cynical there. Just like your reports to the lawyers, make sure what you put up there. Lots of confidence in these batteries. So basically, we started out with an overcharging, then a over discharging scenario. Really overcharging, we decided that, again, we talked about those calculations back. Where was it? So a maximum charge voltage of 3.65 times 4 gives you 14.6, right? So we decided that it'd be good to charge it at 30 volts DC. You know, more than double. Let's see what happens.
You did this in your backyard.
Actually, we kind of did some of it under the ABYC headquarters. So building's still there. So you can kind of see some of the results. You know, on the battery on the right compared to the battery on the left. The left is the result of overcharging and discharging. It basically just swelled up and got there. So the over discharge, we basically again put a bilge pump that was pulling about 16 amps on the batteries and just ran them down and see what happened, and recharged them, and just really just kind of nothing evil happened. It just ruined the batteries basically. So we're kind of like, it's kind of boring. Let's see what we can do to step it up. So you know, what would happen if you put a nail through it, right? So we took a cell, we got our hammer,
It's
nice.
only Knoxville, I guess, too, right?
Yeah, right. So we need to see what would happen here. You know, I don't think this is a typical use for a battery. I don't know. I don't typically take my batteries and use them as a table to nail some wood. But we thought it'd be good to do. So let's take a look and see what happens. Here, I actually had one of my coworkers, Machi, do this. He's Polish, so he did a great job with
You
it.
say Polish?
I said he is Polish.
He is Polish.
Yeah, he is Polish.
There's no fear.
No fear. So here we are. Put the nail through it. You can hear the kids in the background. There's a little park right behind the ABYC headquarters. We have our safety bucket there. We're waiting. We're having a great time. I'm not sure why I decided to go on the downwind side of the field, but you wanted to make sure it got all angles. So you actually do get some discharge. There's some liquid coming out of there, but again, sorry to disappoint. Smoke, liquid, but no fire. But we did shoot a temperature at that, and it got up to around 271 degrees Fahrenheit. So again, before it auto ignite, before real bad things start happening, we're talking about over 600 degrees Fahrenheit we need to get to. So in this situation, wasn't too bad, right? Now, if you took your cell phone battery and tried to do that, I wouldn't do that, because that 271 there could hold it together. All right, so you know, boats, water, what happens when it gets submerged? So we did both a freshwater submersion and a saltwater submersion to see what would happen here. Someone's excited out there. And really, again, nothing spontaneous. Basically, you had some serious DC corrosion happening on On the one is more so actually in the salt water. It was actually worse. It discharged a little fast, but you figure there's more electrical connectivity in salt water, so it went a little faster. Again, nothing horrible. So what happens if we put it in a burning boat? Right? So you have, you know, we talked about a lot of internal things that can make bad things happen, but what about an external thing that could make bad things happen? So let's see what happens. We put it in the burning boat. There's actually a arson investigation class going on, and we said, hey, can we put a battery in your boat? And they said, sure, come on down, we'd love to see it. And they set it up there. So that's what we did. You can see it in the picture there. You can see the blue in the picture there towards the top of the opening there. So it's our little 25 amp hour 12 volt battery there. And this was down in Lorton, Virginia, was where that was. So it was down in Lorton, Virginia. So we have our fine vessel here, is on fire. So here we got our firefighters that are doing some training here.
Was that true scientific research you did there?
No, this is testing in my backyard, so it's not laboratory grade testing. It's how nonchalant that firefighter is about turning and walking away. So we had a nice explosion there. How many thought that was a lithium ion battery? What's that?
Was that your batteries going off?
Is that what you think it was?
I don't know.
Right, so let's just do it again, so you can, now you know, you can kind of look to see what. I got it, guys. All right, so let's take a look to see, you know, what we think may have happened there. So here's the aftermath. So there's the fuel tank, right? That whole situation, you can still see our battery up there. But it was really the fuel tank that blew up. They were supposed to have pumped all the fuel out of it before this, but I guess maybe there's a little something left in there. But yeah, so it's the fuel tank that blew up. It's pretty wild there. And here's the fascinating thing. You can see that battery, it still has 5 volts DC on it after that whole ordeal. And if we take a closer look, you can kind of see the condition of that battery and part of the reason why it still has some voltage on it. So some of those cells are still intact, right? They have a metal housing, metal casing. So you know, it's a consideration, right? So when you go, if you're ever doing investigation after boats burned, you know, just don't think, you know, lead acid, the plastic case melts away. I don't, the electrolyte's gone. This, the metal casing, can cause potentially the battery to be a little hazardous after the fact. So really, what's next? You know, we talk all this focus on lithium. I like to say lithium is probably a flash in the pan. I mean, it's going to be around a while. But there's tremendous amount of research going on to find a chemistry that even has more energy density than lithium, that probably gets away from some of the hazards that are known and associated with some of those there. So I like to say solid state is something that we hear a lot about, and really when you start looking at that solid state, you're basically removing the electrolyte, right? It's basically the entire battery is kind of solid per se. It'll be interesting to see that they think there may be higher energy densities, and again, they're looking at, they actually like 3D print some of these batteries. It's pretty wild how they do it. I think that's going to be next out there. I saw somewhere they're looking at a different, the University of Maryland, University of Houston, we're looking at a much more recyclable battery that's using much more common elements, zinc and basically crab shells, the chitin to make that, which is kind of neat. You think about it, it's like 80% of the battery can be easily recycled from common materials. There's lots of zinc, it's abundant in the Earth's crust. So really it's kind of a lot of evolution there. So key takeaways, right? E13 is your resource, right? It's something that you can look at and get some guidance from. The BMS are the keys, right? They try to keep the entire system safe. It's critical. LiFePO4 is a safer chemistry. Nothing is entirely safe, as you know, but compared to the other lithium chemistries, it is safer from our backyard testing. You really need to look at the system as a whole. You need to start looking at it, not just a battery here. You need to look at it from the complete system, charging, discharging, in its entirety. So there's some key takeaways, and watch out for the cheap stuff. It's going to show up, it's going to be there. Secondary batteries, low quality batteries, it'll eventually make it into the market. It's only a matter of time, and there'll be something new soon, so no worries, we'll be on something next. So as I like to say, as we all focus on lithium again, remember that energy density. I say this is actually my backyard, and here is I think it's an 18-inch section of 3/8 hose that's filled with gasoline, and this is comparison. Oh, yeah, that's not supposed to do that yet. Start here. Just a Bunsen burner, just having some fun. Run. I think this is a B hose, if memory serves me. Notice I have the gas can safely off in the distance there. So
Why don't you do that? Sure.
So I think that's like the equivalent of an ounce of gasoline that's in that hose, if I remember correctly.
That's one reason why I was asking about propane.
Propane, yeah.
You do a similar test with propane because you're starting to see the older boats with these older hoses through the boat. I mean, I know I wouldn't imagine confident to blow the ends out.
Yeah.
I'd say the hose would actually see holding air or holding gas.
Yeah, so I did some testing. It wasn't on with propane, but more that display was a tank that I floated in some propane and created a stratified layer with a grill igniter, and it lit off, and it was pretty exciting too. It's pretty cool. You could actually see the burn was right at the interface between the air and the propane.
So you were simulating Bill's condition.
We were simulating Bill's condition, exactly. Yeah, when we did that test. So yeah. So anyways. All right. So that's really what I had today. Again, talked a little bit about some standards, what ABYC is doing, lithium ion, what to consider. So questions.
Are you aware of any, are you aware of any lithium ion house batteries being fitted into boats? We know of quite a lot in the UK where it's done, and it's done because they're half the price.
Sure.
And this is boats as you think, well, we'll cut corners and put something in cheap. And there've been 2 or 3 that have gone up because a lithium house battery, lithium ion house battery is supposed to be stable in a setting.
Right.
Not supposed to be in a rocking boat. I
Right.
don't know if you've seen any instances of that.
I haven't seen that. I've seen automotive batteries out of wrecked cars being repurposed by some DIYers into boats. And you kind of go, well, the car's been wrecked. Should you be taking that into that? So I've seen that. Yeah, it's just a matter of time that people are gonna, why do it's kind of like ignition protected components. They don't think about it. They're like, this one's $5, $10 cheaper, and they buy that. So, yeah. Not interesting.
So with the BMS being such a key component to these installations, for us as surveyors out in the field, other than looking at general installation, is there any way for us to test the functionality of the BMS with these units?
Not that I'm aware of. I think there's some, Semester has some interfaces where you can get information out of it to check the status, and you can turn the battery on and off and it'll blink. But like there's other brands that are truly drop in, there's no interface.
Yeah,
So
it's built into the.
it's totally built into the case. You can't
Yeah.
see it. You're not gonna do it. I mean, I guess you could try to put a giant load on it and see if it does it, but you're gonna,
beyond the
right?
scope of the job.
Exactly, that's beyond the scope, so.
And so would it be, in my opinion, diving deep into some guy's master vault and the settings and trying to.
I've got two bucks this year, both of them had homemade.
External BMS.
Yes, but they were, one of them was measuring voltage and temperature. Which is supposed to be the two numbers, he had a split gauge.
That was displayed.
That was displayed, and then the other guy had some kind of master volt, a little bitty, like an ice, well, what an ice cube box, it was one of those. Relay type of, it was a box that monitored that whole system, and it had, for lithium battery monitoring. How big those are.
Yeah,
I'd be a big fan of having an audible alarm.
so, yeah,
On the BMS that, if the BMS cuts the batteries out due to some condition,
right,
the alarm goes off. And then some means of being able to test if the alarms actually function.
Todd, the real issue is Steve Mason brought a picture last year to our meeting. And he said what happened is that there's such a similarity between a battery charger for lithium batteries versus regular lead acid,
There's.
gel and AGM. There's a big difference.
Yeah.
He said that when that boat comes up over Fort Annapolis, but they plugged in can't plug in the wrong battery charger. And it cooked that boat out, and they just spent a ton of money on a leach kit.
yeah,
And so he said, that's when Brian talked about the residual amount of energy that was in that battery. And he still said after that boat burned, it still had 8 volts, and they had to find something to hook up to it and discharge that power. And then, remove John Wool from up in New Jersey, he's been doing a lot of stuff about Miami and lithium batteries. He's saying that there's no way to put out a lithium fire. It doesn't matter which one it's been catch on focus. If there's not enough density in the fire product, on the suppression product, we'll put the fire out.
Yeah.
well, and the reaction is producing oxygen
Yeah,
It's just.
and the flammable, right? So it's producing the elements you need.
yeah.
So it's yeah,
And so until they change the chemistry of the fire systems with these batteries, it will still be subject to these unless they put these batteries in lead boxes with no ventilation and no.
yeah. So right, from an ABYC perspective, we try to stop the fire before it even starts.
Yeah.
Right. Everyone's like, well, what do you use to put up? Well, let's not even get there. Let's make sure we don't have a fire.
Knock a leg off the triangle.
Yeah. Yeah.
Four pieces to the triangle now, and we go with the fourth and another second to the right triangle.
Yeah. Right.
Yeah, dude.
Any other questions? All right, well, like I said, I stand between you and lunch, so I'll cut it off
Thank you,
there.
Ryan.
All right.
Thank
Thank
you.
you, guys.
I appreciate your backyard disclosure.
Yeah.
The hell is a kid on the army?
Don't
man?
forget your,
Here.
Thanks, Randy.
Build little model ships.